Right now, foundation model companies and AI startups are spending an order of magnitude more money on silicon than they do on employees. It is common for a team to burn up to 80% of their initial funding entirely on compute. This chart shows rental pricing trends for H100 GPUs. When building financial plans, operators tend to obsess over this single metric, the raw hourly rental rate. They multiply this flatlining curve by the hours they need and assume their infrastructure budget is figured out. Optimizing around sticker price creates a massive blind spot. Identical hourly rates can carry vastly different final costs. With lower-tier providers, you get hit with friction from untuned networking, slow storage, and weeks of engineering downtime spent debugging instead of training. To build a sustainable financial model, operators need to look past the hourly rate and evaluate Goodput, the actual time the cluster spends doing useful, uninterrupted computation. During massive training jobs across thousands of interconnected GPUs, a single hardware failure cascades, bringing the entire cluster to a halt until the system can identify the failure, repair the node, and restart the job from the last checkpoint. This heat map shows node failure rates per hour versus the total nodes you are running. As your cluster grows for larger models, the mean time between failures shrinks drastically. You have less time to complete useful work before the next breakdown. If your engineers are constantly fighting node failovers and struggling with poorly tuned networks to resume training, you are paying your team to act as sysadmins. You are burning your runway on idle hardware and pushing back your time to market. The companies that capture the most market value over the next 5 years will be the ones actively eliminating this Goodput bottleneck, both the operators intelligently matching workloads to cloud providers and the hardware manufacturers physically unclogging the networks. This is the Cluster Max rating chart, showing the 3 specific categories of cloud providers available to builders: gold-tier neoclouds, legacy hyperscalers, and budget silver-tier providers. Each tier handles the hidden costs of Goodput differently. The first major trade-off is storage. A top-tier provider offers high-performance NVMe-based parallel file systems. It costs more upfront, but it drastically reduces the time your GPUs sit idle while initializing massive datasets, pulling your overall total cost of ownership down. The second trade-off is setup and debugging. Operators constantly report that reaching peak network performance on cheaper providers requires weeks of effort. That means paying expensive engineers to tune networking parameters, while your rented cluster sits essentially useless. This chart shows price discrepancy across gold, hyperscaler, and silver tiers. Factoring in storage, networking, support, and Goodput loss, the amount you pay balloons far beyond the baseline GPU instance. A legacy hyperscaler can be over 10% more expensive than a gold-tier provider. A cheap sticker price is a mirage. Cluster economics rely on the specific harmony of your network bandwidth, storage speed, and hardware reliability. You must route workloads based on fault tolerance. Large jobs like LLM pre-training are sensitive. A single failure idles the entire cluster. You need the reliability of gold-tier networks. But inference workloads are different. If a node goes down, frameworks automatically reroute the request. Because inference is inherently fault-tolerant, operators can safely hunt for the absolute cheapest silver-tier capacity globally. The hardware failures will happen, but your software will hide them from the user, allowing you to harvest those massive profit margins. Matching your workload's specific resiliency to the proper provider tier is the single most effective lever an operator has to slash their infrastructure burn rate. To understand why these network delays and cluster downtimes are so severe, we have to look at the physical limits of our hardware. For 60 years, the computing revolution was driven by Gordon Moore's prediction that transistors would continually shrink, allowing for faster, denser chips. We are hitting the physical wall of shrinkage. Transistor speed relies on RC time, dictated by resistance and capacitance. As components become microscopic, resistance increases and switching speeds eventually stall. Processing power is hitting a new ceiling, the friction of data moving across standard copper wiring between thousands of GPUs on a massive server floor. For massive AI models, the time data spends in transit has become the primary constraint. The industry is executing a forced pivot to solve this traffic jam. Capital is flowing rapidly away from traditional architectures and toward wafer-scale manufacturing, and crucially, toward light-based photonic interconnects. Massive market value is shifting away from software labs and toward the hardware companies capable of breaking this physical RC time bottleneck. For founders and engineers managing active runways, the mandate is clear. Stop buying GPUs and start buying Goodput. Allocate your capital with strict discipline. Pay the necessary premium for gold-tier orchestration and high-speed storage when you are training your models. But when you move to serve inference, aggressively source the cheapest silver-tier capacity you can find. Every week your top engineers spend manually debugging a cheap, untuned network is a week permanently surrendered to your competitors in the AI arms race. We can map these friction points into a 5-year investment thesis, a 10-stock portfolio eliminating these bottlenecks. Layer 1 consists of the cloud orchestrators. They possess the massive capital moats required to finance and build global AI infrastructure. The picks here are Microsoft for its massive SaaS integration and Oracle for a network architecture that actively preserves Goodput, and Amazon for its scale and unique ability to provide neo-cloud backstop financing. Layer 2 holds the core hardware providers. These are the foundational silicon designers capturing the raw volume needed as data centers replace their aging clusters. NVIDIA remains the dominant force in both GPUs and critical interconnects. We include AMD as the vital secondary supplier, providing the chips that cost-conscious silver-tier operators rely on to serve cheap inference. Layer 3 is the physical layer. These are the manufacturers systematically solving the transistor shrinkage and RC time physics problems. The manufacturing picks are TSMC for its definitive dominance in the foundry space, and Samsung for its combined logic and memory capabilities, and SK Hynix, which produces the high-bandwidth memory crucial for the fast checkpointing that keeps Goodput high. The final piece of the portfolio addresses the copper wire bottleneck directly. Because the answer to network delay is light, we allocate capital to the companies managing the shift to optical networking. Broadcom and Marvell serve as our vital proxies for custom silicon and the critical photonic shift away from copper. Raw processing power is no longer the metric that dictates success. Over the next 5 years, structural value relies entirely on these 10 companies dismantling the Goodput bottlenecks of the AI economy.